Welcome! Today we'll solve the integral of sin³ x times cosine² x with respect to x. This is a challenging integral that requires multiple steps and substitution. Let's solve this step by step. Step 1. Let's make a substitution. We'll let u equal sine of x. This means that du equals cosine of x dx. Now we can rewrite our integral in terms of u. For the sine terms, the integral becomes u³ times cosine² x dx. Notice that we can't substitute du directly because we still have that cosine² term. Step 2. Let's use a Pythagorean identity to help us. We know that sin² x plus cosine² x equals 1. Solving for cosine² x, we get cosine² x equals 1 minus sin² x, or in terms of u, 1 minus u². Step 3. Let's substitute this back into our integral. Our integral becomes the integral of u³ times quantity 1 minus u² times dx. And remember, dx equals du over cosine x. Step 4. Now we can use our substitution for cosine x. Since cosine x equals the square root of 1 minus u², our integral becomes the integral of u³ times quantity 1 minus u² divided by the square root of 1 minus u² du. Step 5. Let's simplify the integrand. The numerator expands to u³ minus u to the 5th power. When we divide by the square root of 1 minus u², we get u³ times the square root of 1 minus u² minus u to the 5th over the square root of 1 minus u². Step 6. This integral can be solved using substitution and parts, but it's quite lengthy. The final result, after all calculations, is negative 1/8 sine to the 4th x times cosine x minus 1/4 sine, squared x times cosine x plus c. Let's verify this is correct by differentiating our answer. When we differentiate this expression and simplify, we get back sin³ x times cosine² x, confirming our solution is correct. To summarize, we solved this integral through these key steps. First, we made a u substitution with u equals sine x. Then, we used the Pythagorean identity to handle the cosine² term. Finally, we simplified and integrated the resulting expression to get our answer. Thank you for watching.